So, good evening. Today I am going to explain about closed loop control system. Closed loop control system. Closed loop control system. In my last slide, we have seen a open loop control system. Actually, we have seen in last class open loop. Okay, so in last class we have seen open loop control system. Okay, so it looks like the open loop control system looks like I have explained it's like this. Okay, it is a system. It has some input and it has corresponding output, and normally the input is represented by R of t as well as output is represented by C of t, and then the system we can write in terms of time domain G of t as the gain, let us say gain, but afterwards no, so this will be written in terms of the Laplace transformation of input. For all these there are three parameters R of t. This is input, this is output, this is gain. These are the three parameters. So these will be written in terms of Laplace transformations. That is, you can write in terms of Laplace transformation as R of s. Similarly, for C of t, you can write C of s, and then for G of t, you can write G of s. Okay, therefore now you can as I have explained in the last class, now you can write the relation between output, gain and an input. Therefore output is equal to, simple relation, output is equal to gain into input, gain into input. So what is your output here? This is C of s. What is gain? G of s. What is input? R of s. Okay, R of s. So from this you can write the relation for G of s is equal to what is C of s by R of s. This is the simple expression for the gain. A simple expression for gain. Okay, simple expression for gain. This is called the transfer function. Okay, this is called the transfer function. So I'll write in the next slide. So we have seen that the transfer function G of s is equal to, it is C of s by R of s. This is what your transfer function. No? This is what your transfer function. This is called transfer function, sometimes also called as open loop. What? Open loop transfer function. Open loop transfer function, that is nothing but OLTF. This is called open loop transfer function. Now coming to your closed loop transfer function, transfer function. This is coming to the closed loop transfer function, that is CLTF, closed loop transfer function. Okay, here the diagram, the physical representation of closed loop transfer function is something like this. Again, same what you have seen open loop transfer function, the same, the system, this is the input, this is the corresponding your output. Always you can consider as R of S, not necessarily to write all the time C of t, R of t like that. This is your G of S. Now in closed loop transfer function, what will happen, what we have to do is that the part of output can be fed back through a feedback element. This is what your feedback in general. Through feedback element, it should be connected to the input. Likewise the arrow mark. Okay, the part of output shall be fed back to the input. Okay, this is the point where your feedback signal, you are feeding the part of output, you are feeding through the feedback network to the input here. Therefore this is the feedback system. You can write this as feedback system. It also has some gain. That gain is normally represented as H of S. Now here is the point you can represent here as a summer. Here one element will come, that is called a summing point. Normally this will be shown like this. Arrow mark will be, and now this will be your input. Basically this is your input, actually your R of S. You must show R of S here. Okay, this is the summer will be comes here, and for that summing point your feedback will be given. So here the part of output, how you are giving, means either you can give positive or otherwise negative. Okay, so here, so if you consider this feedback, if you want to give a positive feedback, then you have to take the symbol plus here, or otherwise if you consider the feedback must be negative, if the feedback is negative, then you have to give the symbol minus. And remember that always the input, it must be always positive only. I will show you separately again, otherwise. So I will show you. Let us see here. This is your system. This is the summing point. It will be shown like this. This is the feedback network. This is G of S. This is your H of S, the gain of the feedback network, and part of output will be given to this network. This is what your C of S, and now the out, okay, this will be given to the summer actually. Okay, this I am telling you as either plus or minus will be there. For this summer, this is the input. This is your input. This is what your R of S. This always plus. This sign sometimes will be represented either in the circle or otherwise sometimes it can be shown here also. Nothing to worry. This is your closed loop control system. Okay, assume that I have given now positive feedback. Assume that positive feedback is given. Positive feedback is applied, otherwise applied now at the summer point, at the input or at summing point, or at summing point. That point is called summing point. Okay, summing point means assume that the positive signal is given. Assume that there is no minus, only plus will be there. Now you have to derive an expression now. Now here R of S is input, this is C of S, part of output you are giving feedback now. So C of S, you are giving C of S here, means C of S you are giving. Now C of S is, you are giving the C of S through H of S. Therefore the output of here, the output of after H of S is nothing but it is C of S into H of S. This is your output here. Now this is the product. This signal will be applied as feedback, positive feedback. Therefore this much will go as a feedback to this signal. If it is so, now I am assuming positive feedback as I am assuming the positive feedback. Now this is the input going as positive and we are applying positive feedback. Then here this is called the error signal. Here the output of the summing point is called error signal. This is called error signal. That is called, normally it is represented as E of t, error signal, and but we will take its Laplace transformation, that is nothing but E of S. Okay, therefore you consider E of S for the simplification. Therefore here your E of S, therefore you write here E of S. So what is E of S actually? The expression for E of S is equal to, I am writing here, E of S is equal to, if you see the diagram, so E of S, this is positive, this is also positive. This means this total quantity means your E of S is output of the summing point. Here from the summing point output, E of S is nothing but the output of the summing point. Therefore these 2 points are entering here, both are positive, means like your nodal analysis, the entering current is equal to going current, out current, in current is equal to out current. In the same way you can write here, okay, E of S is equal to R of S plus then C of S into H of S. This is expression number 1. This is expression number 1. Now again coming to here, if you see, this is C of S. Okay, now this is C of, this is the output, this is your output. Okay, this is output. Now this is the output, this is the gain, this is the input. Now you write a relation between these three, output, gain and E of S. From here, from these three parameters, I can write the expression like this. So the expression for output, okay, the expression for output, for your simplicity I am explaining. For this is very for beginners, this class will be very useful for the beginners actually. The expression for output, that is C of S, is equal to, tell me what is C of S? G of S into E of S. Output is equal to, already in last slide I told you that output is equal to gain into input, gain into input. Therefore here G of S into C of S, E of S. This is expression number 2. This is expression number 2. Okay, this is your first expression. This is your second expression, E of S. C of S is equal to G of S into E of S. Okay, now you can apply anything basically. You can apply the first expression in expression number 2 means you know E of s value this much, E of s equal to this much. You substitute this E of s straight away here. Therefore, in second slide I will write. So means that, okay, means that, so we know two expression. I will write for your sake again. The first expression is your E of s, your E of s is equal to what? E of s is equal to input R of s plus C of s into H of s. This is now first expression. What is second expression? Output C of s is equal to gain into E of s. This is your second expression now. Now apply 1 into 2. Apply equation 1 into equation 2. This implies what we will get? What we will get? C of s is equal to, that is G of s, E of s, in place of E of s you substitute that is R of s plus C of s into H of s. Okay, this implies what we will get? This is C of s is equal to G of s into R of s, is it? Plus again multiply this G of s into this with this one, means G of s into C of s into H of s. This implies, now this is C of s, here you have C of s, therefore take this product into left side, means C of s, bring this one to the left side, means minus G of s into C of s into H of s, is it? This is equal to what remains on the right side? Only this component, G of s into R of s. This implies, here take C of s as common, 1 minus G of s into H of s is equal to your G of s by R of s, is it not? From this you bring a relation, you write G of s is equal to, G of s is equal to what will come? From this, from that relation, okay, I will show it from here, you write, okay, from there, no, you write G of s is equal to, this implies G of s is equal to, what is actually output by C of s by R of s, no, C of s by R of s, है ना, C of s by R of s, then C of s, bring C of s by R of s, okay, C of s by R of s is equal to, C of s by R of s is equal to, it is G of s by 1 minus G of s into H of s. This is what your transfer function. This is what your transfer function means. C of s by, you have to bring the relation for C of s by R of s is equal to, it is G of s by 1 minus, it is G of s into H of s. This is what closed loop, your CLTF, that is closed loop transfer function. So remember that, and one thing is, if you further, this is for positive feedback, this formula, this is very important formula, this is very important formula, which is for if the input, if the feedback is positive, otherwise for the positive feedback, this is for positive feedback, okay, this is the formula. Similarly you can apply for negative feedback also. Negative feedback, just for your understanding purpose, you can just try on your own. In next class, next slide, I will explain you about that also. In negative feedback, you will have C of S by R of S as gain by 1 plus G of S into H of S. This is for negative feedback control system. This is the again closed loop transfer function again for negative feedback. This is the closed loop transfer function with negative feedback. This is the closed loop transfer function with positive feedback. Okay, so we'll stop here and we'll continue next slide. Thank you.